Kepler's third law says that the radius cubed of an orbit of one planet divided by the period squared equals the radius of the orbit cubed of another planet divided by the radius time squared. Since we're comparing these, you can use any units you want, and the problem will kick back the units that you use. So what's nice is you don't have to convert to meters or seconds. You could use kilometers or hours. You could even use billions of meters as your unit. So just make sure you keep the same thing on both sides. So the easy way to remember if it's r cubed or t squared, I always think of the Rubik's Cube. So r is the one that's cubed, and then t is squared. And then you also can even flip this if you want. As long as you flip both sides of the equation, you could do t squared over r cubed of one planet equals t squared over r cubed of another planet. That works as well. So here's an example. If the Earth is 150 billion meters from the Sun and Mars is 228 billion meters from the Sun, how long is a year on Mars? Well, first we have to remember that the Earth orbits around the Sun, as well as Mars. Mars orbits around the Sun, so they both orbit around the same central object. So that means that we are allowed to use Kepler's third law. So we use r cubed over t squared for the Earth equals r cubed over t squared for Mars. So remember, we can use whatever units we want, so I'm going to use units of billions of meters. So this really just becomes 150 over 1 year equals 228 cubed over the time for Mars to orbit squared. And then we can actually flip this. Remember that as long as we do the same thing to both sides, it's okay. So we get 1 squared over 150 cubed equals t squared for Mars divided by 228 cubed. So remember, I want time for Mars, so I'm going to multiply both sides by the 228 cubed. And then the other side has to do the same thing to keep it an equality, 228 cubed. So then when I do that and I get the mathematics of this, I get 3.5 equals the time squared, or the time for Mars to orbit ends up equaling 1.87 years. And those are Earth years. And then I actually went to Google to check this out just to make sure my answer was correct. And Google said that it was 1.88 years for a year on Mars. So I think this worked out pretty well. Give ourselves a nice smiley face.